Asteroids are nature's way of asking, hey humans, how is that space program coming along? Have we made any progress towards thwarting a big rock that has the potential to set pretty much everything on fire? Watch on to learn about asteroids and how we can shoo them away from Earth. Living in the 21st century, it might appear as if we were always aware of the reasons that led to the extinction of a certain species. But it was only 1813 when an essay published by Georges Cuvier first proposed that the now extinct species had been wiped out by periodic catastrophic events like flooding. Cuvier was a French naturalist and zoologist. His most significant accomplishment was a massive one. Cuvier established that elephant-like bones found in the USA belonged to an extinct megafauna species, a mastodon. Coming back to his hypothesis, it was not only floods that led to the extinction of the now extinct species. That's what the Chicxulub impact crater buried under the Yucatan Peninsula in Mexico tells us so. An impact crater is a bowl-shaped depression caused by the impact of an object like a meteorite. The Chicxulub crater formed when an asteroid struck the Earth nearly 66 million years ago. So what was the result of this impact? Sudden mass extinction of almost 3/4 of plant and animal species on Earth. This event was known as the Cretaceous-Paleogene extinction event, or to cut it short, the KPG extinction event. Google the solar system. Excellent high-quality images of the sun and the revolving planets will pop up. But not many photos will show you the rocky stiff left over as the planets were forming. A rock of a size greater than 1 meter is an asteroid. Smaller rocks greater than 1 micrometer but smaller than 1 meter are what we call meteoroids. Meteoroids are lumps of rock or iron that orbit the sun just as planets, asteroids, and comets do. How massive would such an asteroid be, one that nearly wiped out everything on planet Earth? Tons of kgs, thousands of miles, right? The one responsible for the KPG extinction event was only 10 kilometers wide. When it comes to asteroids, the kinetic energy they impart on the Earth makes them a fearsome phenomenon. Hundreds of tons of these rocks enter Earth's atmosphere every day. These meteoroids burn on their entry into the Earth's atmosphere, and once burned, they are called meteors. Don't be alarmed though, most of them are smaller than a grain of rice, so we're safe. Except when meteoroids don't burn into meteors, they leave an impact on our lives, just like the one that happened on November 30th, 1954, when it hit Ann Hodges' home in Alabama. Ann remains the only documented person who survived a meteorite impact. So we could say that Ann did better than about 3/4 of the species that were wiped clean from the surface of Earth during the KPG extinction event. Of course, you could say that was luck on her part, but don't underestimate luck. You will need some of that if an asteroid decides to change its trajectory towards Earth today. All this talk about asteroids makes one wonder, where are all these asteroids right now? In the asteroid belt, of course. Located between Mars and Jupiter, almost half of the mass of this belt comprises 4 giant asteroids. These are Ceres, Vestas, Pallas, and Hygeia. Other than asteroids, this belt also contains minor planets. So as long as these asteroids are in the asteroid belt, we can continue to watch Netflix and chill. But there are thousands of asteroids whose orbit crosses with Earth. So what are the chances of one of these dusty rocks colliding with Earth's surface and firing up our planet? Well, this becomes more predictable by studying craters on the Moon. The impressions on the Moon can indicate how often different sized impacts tend to happen. Here's what we know so far. A Hiroshima-level meteor or asteroid explosion happens at least once on Earth every year. Are you surprised by the underreporting of such events? Most of the time, we're not even sure it has happened because most of our land is covered in water. No wonder we don't hear the bangs made by these 10-meter wide asteroids. On the other hand, a 20-meter asteroid can strike the Earth's surface at least twice a century. And it has happened once already during this century. For example, the Chelyabinsk meteor entered Earth's atmosphere over the southern Ural region in Russia on February 15, 2013, and made things shine brighter than the sun. So what about asteroids big enough that can create Arizona's Barringer Crate? Well, They would have to be at least 100 meters wide, and the chances that they would find their way to Earth are like once in every 5,000 years. For a 1-kilometer asteroid, we would have to wait around 100 million years. If the last mass extinction was 1 million years ago, the science of deduction tells us that such catastrophes happen only once in 1 million years. Good news, eh? We can relax a bit. How devastating can a single asteroid be? It's an interesting question. Multiple factors determine our fate in case of such an event. Some of these factors include the angle of impact, point of impact, the composition of the incoming asteroid, and the speed at which it enters the Earth's surface. The Guardians of the Galaxy think that we are safe right now. It is because there are no signs that suggest an asteroid might be headed towards the Earth. But what if there was one? What would be the best defense against an invading rock that has the potential to wipe the Earth clean from pretty much everything? If we can change the trajectory of an incoming asteroid to a certain degree, we will certainly avoid the impending disaster. Like sending multiple smaller spacecraft to collide with an asteroid one by one could work, or launching projectiles from the moon, or using defunct satellites as kinetic impactors to deflect an incoming asteroid are some of the strategies that the brightest minds have considered at NASA. The near-Earth asteroids are always making people at NASA sweat a lot. Maybe one of these strategies will keep us safe in the future. 66 million years have passed since an asteroid led to a mass extinction event. Will such an event happen again? We are not ruling that out entirely, since it has already happened. However, guessing when it will happen is an even more challenging question to answer. It's like playing that classic Minesweeper game. You never know when you're going to run out of luck. If you loved what you just watched, make sure to smash the like button and subscribe to this channel.